Okay, so we're going to start out with geometric mean. Geometric mean just says it's just when the means are the same in a proportion, the mean proportion. And when I cross multiply, I end up with x squared equals 36 times 4. X squared is equal to 144. I take the square root, x is equal to 12. So that was that one. That one wasn't so bad. Next one. This one's a little bit dicey. So you have your altitude to hypotenuse relationship, and so I do the shortcut. I know that if I square a leg of my big right triangle, basically my leg of my right triangle is the geometric mean of part of my hypotenuse. So part of my hypotenuse times my whole hypotenuse. So, and so my way of remembering it is leg squared is equal to part times whole. We have the other relationship, which is also if you square the altitude is actually the geometric mean of the parts the hypotenuse are split into. The one I'm going to use for this is because I'm given a leg and I know this part, and my whole is going to be x plus 5, I can say radical 6 squared is equal to part times whole. 6 is equal to x squared plus 5x. I subtract 6 from each side because when you're solving a quadratic, you set it equal to 0. Now, for purposes for this class, you should have learned how to factor last year. Most of you didn't know how to factor. If you did, I'll try to do a little refresher here. So basically, you split this up into 4 parts, and you're trying to find these 2 parts right here. You're trying to find these 2 parts right here. And so what do we know about those 2 numbers? I know that those 2 numbers add to be 5, and they have to multiply to be negative 6. So they always add to be your middle term and multiply to be the product of your first and last term. So you have to think about that. Okay, so what numbers multiply to be negative 6 and add to be 5? Okay, and so for this, it's going to be plus 6x minus 1x. And then this is going to be minus 6. Okay, because positive 6 times negative 1 is negative 6. Positive 6 plus negative 1 is 5. So from here, you find the greatest common factor of these terms, which in this case is x. When I factor in x out of both parts, I end up with x plus 6. Here, I find the greatest common factor, which is a negative 1. I factor a negative 1 out, I end up with x plus 6 again, which is lovely, okay? Because now they have an x plus 6 in common. I'm going to actually factor that x plus 6 out times x minus 1 is equal to 0. This is super helpful because now I can solve this, okay? Because I know if 2 things multiply to be 0, one of them has to be 0. So either x plus 6 is equal to 0 or x minus 1 is equal to 0. So I subtract 6. X could be negative 6, add 1, or x could be positive 1. When we talk about this problem here, x can't be negative 6 because you can't have negative measurement, so we have 1 here. And so we can do a little quick check. I know short leg over hypotenuse, so 1 over radical 6 should be equal to short leg of the big triangle, okay, over the hypotenuse of the big triangle, which is 6. And if I cross multiply, is radical 6 times radical 6 equal to 6 times 1? Well, yes, 6 is equal to 6. So that actually checks out. All right, next one, this is that relationship. Again, I always say altitude squared is equal to part of the hypotenuse times the other part of the hypotenuse, or maybe you've learned short leg over long leg is equal to short leg over long leg. Regardless of how you do it, it ends up being x squared is equal to 1 times 3. X squared is equal to 3, and when you take the square root of each side, you only need the positive root because we're talking about measurement. X is equal to 3. Or radical 3, excuse me. Okay. Next one, it has multiple parts. So you show your work on the first one. Things that I know that this whole side is 7. And then I have my 2 parts, because I have those formulas. There's one part is here, which actually goes with this leg, because they're part of the same triangle. My other part, because I've been talking about the part times whole, is this part, and then this leg goes with that. So you just go through, and also the last thing you know is that altitude squared is equal to part times part. So you just pick whichever one. I'm going to say x squared equals 2 times 5, because that's the altitude squared is equal to part times part. Okay, so I have x squared is equal to 10. X is equal to radical 10. And you really can't do anything else with that, that you can't simplify the radical 10. I go over and I'm like, okay, well, let me solve for y. So I have y squared is equal to part of my hypotenuse that's adjacent to it times my whole hypotenuse. So y squared is equal to 14. Y is equal to radical 14, and radical 14 can't be simplified beyond that. Last one is z squared is equal to 5 times 7. Z squared is equal to 35, so z is equal to the square root of 35, also can't be simplified. So there are your 3 values for that. It was radical 10, radical 14, and radical 35. Okie doke. Let's go to this guy. All right, something very similar. This is a 3, 4, 5 right triangle. I have the same relationship though. I have my one part of my hypotenuse. I have the other part of my hypotenuse. And then I have, of course, my whole hypotenuse. And so I know this leg goes with this part, and this leg goes with this part, and then I have my altitude here. So it doesn't matter which one you solve for first. I'm going to go with this one. So things that I know 3 squared is equal to 5 times b, part times whole. Hypotenuse over leg equals hypotenuse over leg, and you can cross multiply. It's the same thing as the proportion. My next one that I could solve, I also know 4 squared is equal to 5 times a. Okay, again, hypotenuse over leg equals my big hypotenuse over the corresponding leg. And my last relationship is h squared is equal to part times part, which is going to be a times b. And that's that short leg over long leg equals short leg over long leg, that same proportion. So I obviously cannot solve this one right here because I have 2 variables. So I go through 9 is equal to 5b. I divide by 5, divide by 5, b is equal to 9/5. An acceptable answer. I'm just going to leave it that way. My next one, this is going to be 16 is equal to 5a. Divide by 5, divide by 5. A is equal to 16/5. Now I can solve for a and b. Okay, I know a is 16/5 and b is 9/5. Okay, and so we have h squared is equal to 16/5 times 9/5. So when I multiply across, I know I'm going to take the square root, so I'm going to do this a little bit funky. So it's just going to be 16 times 9. I'm actually not going to multiply those out over 25. The reason why I'm not going to multiply them out is because I know that I'm going to have to take the square root, and you can actually take the square root of each part, so you don't have to deal with a big number that you have to simplify. So h is going to be, well, the square root of 16 is 4, the square root of 9 is 3, and the square root of 25 is 5. So h is going to be 12/5. Okay, you can go through and do your whole multiplication process, do 16 times 9 and simplify, but I think that if you have a perfect square here and you know you're going to have to take the square root, it can make things simpler, especially on tests that are non-calculator. So we have b is 9/5, a is 16/5, and c is 12/5, and whatever the decimal equivalent is. All right, number 12 in the accompanying diagram of right triangles, AB is equal to 5, AD is equal to 4, find the length of BC. So for this, I would have to do Pythagorean theorem twice, because I need two sides to solve for a third side, essentially. So I need to find this side first. So I do Pythagorean theorem. Some of you will recognize this is a Pythagorean triple. 4 squared plus BD squared is equal to 5 squared. 16 plus BD squared is equal to 25. BD squared is equal to 9. BD is equal to 3. But most of you can tell because it's a Pythagorean triple. Now I go through, do Pythagorean theorem again. In this case, it's defined BC. So I know BC squared plus DC squared is equal to BD squared. BC squared, so it's BC squared, plus 1 squared is equal to 3 squared. BC squared plus 1 is equal to 9. I subtract 1. BC squared is equal to 8. The distance from B to C is equal to the square root of 8. The only thing that we have to do is we have to make sure that we simplify our radical. A lot of you this is very familiar. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So I know that this 8 has a 4 on the inside. So I take that square root, bring it to the outside, that perfect square, and a 2. And so my answer is 2 radical 2. An 18-foot ladder. Okay, so again, make sure your drawing is accurate, even if it looks goofy. Okay, I wouldn't climb on this ladder. I'll lean against the wall. The base of the ladder is 9 feet up on the building. And the ladder itself is 18 feet. How many feet up the wall to, oh, wait, sorry, 9 feet from the building, sorry. Don't do that. All right, sorry about that, guys. Is 9 feet from the building. There we go. How many feet up the wall to the nearest tenth of a foot is the top of the ladder? Now here's something that's really interesting. I already know without doing any work, I see something. I see my right triangle and I see that the hypotenuse of my right triangle is actually twice one of my legs. So this would have to be a 30, 60, 90. That only happens in a right triangle. If one leg is half the hypotenuse, it's always a 30, 60, 90. So I know for sure this has to be 9 radical 3. Okay, only because I know that. Now, if you aren't really good at, looking at those things, you can see this right triangle and we can do Pythagorean theorems. This is 8x squared plus 9 squared is equal to 18 squared. So this is x squared plus 81 is equal to 324. I subtract 81. I end up with 243. X is equal to the square root of 243. Okay. Now you use whatever method you want. I'm just going to use this basic method. So 2 doesn't go to 243. 3 goes into 243 81 times. 3 goes into 81 27 times. 3 goes into 27 9 times. 3 goes into 9 3 times. And 3 goes into 3 once. And so I know the square root of 9 is 3. I know that this has a perfect square of 9 in it, so that's also a 3. And I'm left with a 3 here that is not a perfect square that gets left in the radical. And so that's where I get my answer, which is 9 radical 3. And don't forget your units. Your units are feet. Okay, and if it doesn't ask you to, so this says to the nearest tenth of a foot, which is my mistake. I should be reading. Is 15.6 feet. And either of them are an acceptable answer. So, Seth Roberts and his construction crew are adding a recreation room to a house. They've used a tape measure to determine if two walls are right angles to each other. Their measurements of sides of a triangle in the corner between the two walls are 12 inches, 12 inches, and 17.4 inches. Do the walls meet at a right angle? So if they met at a right angle, then 12 squared plus 12 squared would be equal to 17.4 squared. Okay, and so that's going to be 144 plus 144. And then this is going to be 302.76 is 288. Ooh, that's too many eights, sorry. Is 288. Okay, let me go back to this. Okay, I don't know why this expanded like this. Now I can't erase. Okay. 288 obviously is not equal to 302.76. So basically you would say something like, it doesn't work in Pythagorean theorem. Pythagorean theorem doesn't work on this, so it can't be a right triangle. And actually from what we know, 302.76 is actually greater than, so this would be an obtuse triangle. Just an extra piece of information to practice. Okay, this one says determine whether each set of measurements can be measures of the sides of a triangle. So the first thing, see if it can be a triangle, and then whether it's acute, obtuse, or right. So don't go straight to your Pythagorean theorem. So I have a 12, a 16, and a 20. Okay, and so I look at my longest side. Is my longest side, the measure of my longest side, less than the sum of my other two sides? Is 20 less than 28? And it is. So that's the first part. Okay, so now I know it's a triangle. Now I set up Pythagorean theorem. Always make sure that your C, because it should be, you have your C squared and then you have your A squared plus B squared. Just make sure that your longest side is what you substitute in for C. So this is going to be 12 squared plus 16 squared. That's 400. 12 squared is 144, and 16 squared is 256. This is 400 is equal to 400. So this must be a right triangle, because when you do Pythagorean theorem, they are equal to each other. All right, to the next one. First thing, always figure out if it's a triangle. Is 32 less than 30 plus 16? Is 32. Making all sorts of mistakes. Is 32 less than, there we go, 46? Yes, so I know it's a triangle, so now I do Pythagorean theorem. 32 squared, or converse of, is what to 16 squared plus 30 squared? So I have 1024. This is 256 plus 900. Okay, so 1024 is what to 1156. So 1024 is less than, so it must be an acute triangle. Okay, first thing, you determine if it's if the side measures represent a triangle. So always do largest side, 6/5. Is that less than 2/5 plus 4/5? Okay, so is 6/5 less than 6/5? Nope. So it is not a triangle. So you don't have to finish this. You don't have to determine if what kind of triangle it is, because it's not even a triangle. Next one. So first thing, determine if it is a triangle. I know you have calculators and you can use decimals for this, but I am going to go through and show you how to do this algebraically, because everyone can use some algebra work. Okay, so I have things in radicals here, so I'm going to put everything in a radical. So what I do is I take my plain number, my integer, and I square it and put it underneath the radical, because radical 36 is actually the same thing as 6. For my 2, I actually am going to change that to a radical 4, and then I have my radical 2 here. This is going to also be radical 4, because that's the same thing as 2. And then I have my radical 7. Now I can compare just to make sure which one's the largest side. So I have 36. This is going to be radical 8, and this is going to be radical 28 as I multiply. Now, first thing I determine is whether or not it is a triangle. So I say, is 6, which is my largest side, this is my largest side, I would go back to my integers, is that less than my radical 8 plus radical 28? So you can put this in your calculator and look at the decimals to make that determination. Square root of 8 is close to the square root of 9. Square root of 9 is 3, so I'm going to say that this is like 2.7, something around there. Square root of 28 it's a little bit more than the square root of 25, which is 5, so I know that this is going to be 5.2 or something like that. Even if I just round to the lowest number, I can see that 5 plus 2 is 7, okay? And remember, these are just approximations. 5 plus 2 is 7, so I know it's going to be bigger. So yes, it is a triangle. Okay, so next thing we do is we do our Pythagorean theorem. Now 6 was the longest side, so 6 squared is something to 2 radical 2 squared plus 2 radical 7 squared. And you can go to these values too and use them. I'm just using the original values because I want to remind you of something. So when you square a 2 radical 2, make sure you square the 2. So that becomes a 4. And the radical 2 squared is 2. This one, I square the 2, it's a 4. And then radical 7 becomes a 7. And so 36 is what? 2/8 plus 28. 36 is something to 36 is equal to, so it has, it's the right figure. All right. So Ryan leaves his house to buy milk at a nearby store. Okay, so here is our friend Ryan here to start with. He walks 140 meters up one street. And then turns 90 degrees to the left and walks another 184 meters to the store. Okay, to get home, we walk straight through a field from the store to the house. How many meters long is the walk home? So that's what we're trying to find. So this is 140 here. Sorry, I should have. Okay. And so this is just the hypotenuse. So it's going to be 184 squared plus 140 squared is equal to x squared. So, 33,856 plus 19,600 equals x squared. It's going to be 53,456 is equal to x squared. We take the square root, okay? X is equal to the square root of 53,456. And we can go through and simplify, or we can round our answer to the nearest tenth. I'm just going to go through. So we have 5,300, or 53,456. I can say this. I take this, divide by 2. I get 26,728. I take that, divide by 2. I end up with 13,364. I can take that and divide by 2. 6,682. I can take that and divide by 2. I end up with 3,341. 13 goes into that 251 times. And I really can't do much from there. So if we simplified, I'd have the square root of 4 is 2, the square root of 4 is 2. So I have 2 2's on the outside, because those are things I can take the square root of. And so I'm left with, so this is 251 times 1. I'm left with a square root of 33,000, or 3,341. I can say numbers. So one of your answers could be 4 times 3,341 meters. That's kind of a ridiculous answer. To give you a better idea, you can put your calculator, and so it's going to be approximately, and that's what that means, 231.2 meters. Okay, so for the next one, you're finding x and y. Looking at this here, y is going to be a little bit more complicated, but we still need a part. So we know the hypotenuse of a 30, 60, 90. And what do I know about the hypotenuse? Well, I know the hypotenuse is equal to my short leg times 2. 2 times my short leg. 2 times my short leg. So if my hypotenuse is 22, well, my short leg, which is this leg right here, well, this one has to be 11. And that's super helpful, because now I know, since this is 11, well, I have enough information to find the hypotenuse here, because I know for a 45, 45, 90, my hypotenuse is equal to my leg times radical 2. And so my hypotenuse is going to be 11 radical 2. And so that's my x value there. Y, well, I look at y right here. I know if this is 11, then this is going to be, because this is my short leg, this is my long leg, I know my long leg is equal to my short leg times radical 3. So the long leg of my 30, 60, 90 has to be 11 radical 3. Okay, and then I also need to find the other part to find y, which is 11. Now, if I want an answer to be precise, my answer is just going to be, well, y is the sum of these two parts, so y is going to be 11 plus 11 radical 3. And you can actually put that in for your answer. So for y, you can actually put in, and you can put it in parentheses if you want, 11 plus 11 radical 3. And there you go. That's one of your options. Oh, that was for y. Ugh, good Lord. You guys have the idea. Okay. And then, of course, x was 11 radical 2, which you guys can do. Okay, next one, finding x and y. This is super simple, because this is my hypotenuse, this is my short leg, this is my long leg. I know my hypotenuse is 2 times my short leg. If my hypotenuse is 26, it's going to be 2x, so my x had to be 13. I also know my long leg is my short leg times radical 3. My long leg is y. My short leg is now, I know that's 13 radical 3. And so those are your answers for those two. Length of a diagonal of a square. Ooh, let me just make sure. Did I skip one? Oh, I did skip one. Okay, it says find the altitude in my isosceles triangle. Okay, so I go through and I draw. I'm big on drawing. Okay, it's an isosceles triangle. The base is 10, and it has congruent side lengths of 9 and 9. So this is actually kind of interesting. When you draw in the altitude, it actually cuts it up into two congruent parts, okay? Anytime. These two triangles are congruent, actually, by side angle side. Or actually, yeah, side angle side you could do, because this would be reflexive property, this angle, actually not this side, but yeah, the triangles are congruent. Anyway, so this right here is 5, and this is going to be, let's call this x, that's my altitude, and so I'm just going to use Pythagorean theorem because I know nothing about the angle. So 5 squared plus x squared equals 9 squared. 25 plus x squared equals 81. 81 minus 25 is 56. X is equal to the square root of 56. 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. 7 and 1. I know that the square root of 4 is 2, so I know there's going to be a 2 on the outside. And the thing that's not a perfect square, and I think it's confusing that I circled that, the thing that's not a perfect square actually is left on the inside, so it's going to be 2 radical 14. 27, what's the length of a square with a diagonal, or with side, the diagonal of a square with side lengths of 7 radical 2? So things we know about squares. I know this is 7 radical 2. I know all the other sides are the same. I know this is a right angle. If these two sides are the same, this has to be a 45, 45, 90. And the only thing I know about a 45, 45, 90 is the hypotenuse is equal to the leg times radical 2. Here, this is the hypotenuse of my right triangle. My leg is 7 radical 2. And so it's going to be 7 radical 2 times 7 radical 2. Radical 2 times radical 2 is 2, so it had to be 14. Okay. It says find Fi in the figure below. Alrighty. So let's do this one. So you're given that this is 5, and it says in the figure below find Fi. Well, Fi isn't that bad, because if this is 10 and this is 9, the whole thing is 19. Okay, so I know 5 squared plus Fi squared is equal to 19 squared. So that's going to be 25 plus Fi squared is equal to 361. I subtract 25, Fi squared is equal to 336. I take the square root. Okay, I have the distance from F to I is equal to the square root of 336. I need to simplify that. I'm going to do my method. 336 divided by 2 is 168. 168 divided by 2 is 84. 84 divided by 2 is 42. 42 divided by 2 is 21. 21 divided by 3 is 7, and 7 and 1. And so we have in 336, it has perfect square factors of 4 and 4. So and the square root of 4 is 2. So I know I'm going to have 2 2's on the outside, And then what was left was the 3 and the 7, 21 on the inside. So the distance from F to I is going to be 4 radical 21. On to the next one. So it says find GF. Okay, GF is part of this 30, 60, 90. I know the hypotenuse. What do I know? The formula that I have for hypotenuse. Hypotenuse is equal to 2 times my short leg. If my hypotenuse is 10, my short leg, which is FG in this case, and I know it's a short leg because it's opposite my 30-degree angle, I divide by 2, and the distance from F to G is going to be 5. So that's just your 30, 60, 90 relationships. Next one, GH. Okay, well, we use what we know from the last problem. So I go back up. I knew that FG was 5. Okay, and that's my short leg. This right here is my long leg. I know that my long leg is equal to my short leg times radical 3. And so your answer is just 5 radical 3 there. And that